Hello students, today we are doing lesson 9.3, which is on factoring perfect square trinomials. So we're going to go backwards and remember some of the things that when we did it forward, which is multiplying, and then we're going to work backwards with factoring. So let's go back to how we did perfect square trinomials, since that's the title of your page, of your lesson. Okay, so this was a square, and when we solved this or multiplied this, we took it and wrote it out twice since it's squared. So now we're going to multiply it times each other, and this answer came out to x squared plus 2xy plus y squared. So I didn't show the in-between step because we've already done that. So we're going to look at a couple of trends here. Let's do one more. We have y plus 4 squared. And remember, that means y plus 4 times y plus 4. And when I multiply that out, I get y squared plus 8y plus 16. Okay, before I go on and show you a few more examples, let's talk about working backwards. So to know why something is a perfect square trinomial, because you need to know how, when you're looking at it, is that a perfect square, is you say, is this a square? Yes, because it's y times y. And is this a square? Yes, because it's 4 times 4, or 4 squared, right? So when I now, to make sure that the middle number is also part of that perfect square, is I take this number, the 4 times 4 that made 16, and I either add them or subtract them. And I say 4 plus 4, or let me put it on the other spot. 4 plus 4 is the 8. Okay, so that's what makes it a perfect square, is when the two that multiplied together also add together to make the middle. Okay, let's look at two more. If I had x plus 3 squared, that would be, I'm not going to write out this part of it, okay? I'm just going to write out what the answer is. It would be x squared plus 6x plus 9. So see, that 9 is a perfect square, 3 times 3. And then when you add that 3 plus 3, you get the 6, okay? And x is x times x, which is a perfect square. Okay, and then last one, let's do one with minus sign. X minus 1 squared is going to be x squared minus 2x plus 1. So this one is different because it's a minus sign. Remember, when we do it, when we're multiplying it like this, remember the last one is negative 1 times negative 1, which makes a positive 1. And then when we're adding it, so see, I have 1 times 1, but when I add 1 times 1, I get 2, but it's negative because of these negative signs or minus signs right there. Okay, that may have sounded like a lot to go through, but let's go ahead and start, and maybe it will make more sense once you see some of the examples. Okay, so, sorry, I have a little bit of a sore throat today. Example 1. We have x squared plus 10x plus 25. Remember, factoring is going backwards, so it's like taking this problem right here and working backwards to get this, or really working backwards to get this. So we're going to do that here. First, I'm going to ask myself, is there any number I can take out of this? Because you want to factor out any numbers first, and there is not. So now I'm going to look at if these are perfect squares. So this is, because it's x times x, and 25 can be 5 times 5. Before I say this is a perfect square, I need to make sure that that 5 times 5, when added together, makes that middle term. Okay, we're going to have some later on that don't do this, so I want to make sure that you really understand that that has to work. The 5 times 5 has to be 5 plus 5 to equal that 10. Okay, so I'm going to make my two little parentheses here, and I know x is going to be in the front because I have x times x, and I know 5 is going to be at the end because I have 5 times 5. And then my adding or subtracting signs are going to be whatever this one is in the middle. So it's a plus, so I'm going to do plus and plus. Okay, I do not want you to leave it like this. I want you to make it into a square because it is the exact same thing. We have squared. Okay, let me give you, I'm going to do a few more examples than what the book has. Let me give you one to try on your own. So let's call this example 1B because I have a different example too. Okay, let's do m squared plus 24m plus 144. Okay, so hit pause and try this one on your own. Remember, you're going to have two parentheses, and you're trying to find out the square root or the squares of these. Okay, go ahead and hit pause now. Okay, now that you're back, we're going to do m's at the front because m times m is m squared, and then 144 is 12 times 12. So I'm going to do 12s at the end and a plus sign. Now, before I go on, or before I put down that 12, I should have checked, or you should have checked, that 12 plus 12 makes that middle number, and it does. So now my final answer is m plus 12 squared. Okay, let's go on to example 2. So example 2 is a little bit harder. We have 4x squared plus 12x plus 9. So you always ask yourself, can I take out a number first? Well, here I could take out a 4, and I could take out a 4 from this one, or factor out a 4, but this one does not. So, and then this I could take out a 3, and this one I could take out a 3, but I can't take out a 3 here. So there are no numbers to take out. So I'm going to go ahead and figure out my two numbers. So this has 4x squared, so that's 2x times 2x. And this is 9, so that's 3 times 3. So I'm going to go ahead and write those in here. Okay, and I have my plus signs. Now somebody's going to say, well, look, this 3 times 3 does not work. 3 plus 3 does not work with 12. But on these, when you have a number in front, it's a little bit different. So let's look at what I wrote down here and see if it's going to work out. So my 2x times 2x is 4x squared. That one works out. And my 3 times 3 is 9. That's going to work out in the back. But let's look at the middle numbers. So here I have 6x. And 2x times 3, I also have 6x. So do you see how now when I put my like terms together, I'm going to get 12x. And that's what I have up here. So it works out. So it's a little bit different when you have that first number in there. You're really having to look, well, checking, when you're checking, you're really having to look at that check. Okay, so this was what my answer was. These were just checking it, right? So this was my answer. And since those are both exactly the same, you need to write the square on it. So this is my final answer. Okay, let's try another one on your own. Let's see if you can figure this one out. It is a little bit different, but I think you can do it. So let's do x squared y squared minus 8xyz plus 16z squared. Okay, so first we're going to ask our signs we're going to ask ourselves, is this a perfect square? So on this one, I could have xy times xy, and on this one, I could have 4z. So that's my only hint I'm giving you is both the first one and the last one are perfect squares. So now I want you to pause the video, work it out yourself, and make sure that this is supposed to be in the middle. Okay, go now. Okay, now that we're back, I'm going to take my numbers here, and I'm going to put the xy in the front, because that's what I got here. And I'm going to put the 4z at the end. And then what signs do I put in there? Remember, I told you whatever the middle one is, that's what you're going to put here. Because remember, I want two negatives to make this positive, right? And those two negatives will keep this negative. So that is my answer. And if I put it as a square, it's going to look like this, right? So that should be my answer, but I'm just going to work it out real quick. Okay, so my first one times my first one is going to give me x squared, y squared. My last ones are going to give me plus 16z squared, so I'm good so far. And now I'm going to work on my middle ones. So xy times negative 4z is negative 4xyz. And negative 4z times xy is negative 4xyz. So you see how those two make my middle number of 8xyz. And then the rest of these stay the same. So it does check. So this is my answer. Okay, hopefully y'all got that one. Okay, let's move on to the last one, example 4. And that is xy minus 4x plus 9. Okay, so first thing I'm going to ask myself is this a perfect trinomial? So this is x times x, and this is 3 times 3. But when I take the 3 times 3 and say 3 plus 3, that does not make this 4. So this is not a perfect trinomial. So we do not have to do anything because I cannot factor this. Okay, so this is just going to stay that way. It can't be factored. You will have at the beginning of your homework a whole bunch of problems where all you're writing is yes or no to whether or not it's a perfect trinomial. Okay, so you don't have to factor them. You just have to say yes or no. And then later on, you'll be factoring some. Okay, so that's it for today. Thanks.